Let's start off. Comes on everyone. I hope everyone has tried the homework problem. Told you it's a good one. Let's see if you got something about this. So how do we start this? The first thing, time taken to cross the river. Let's start from there. Now tell me one thing, no matter how much the river flows horizontally, does that going to affect the motion in the vertical direction? This we have seen even in projectile motion also. A horizontal acceleration or a horizontal velocity cannot affect the motion in the vertical direction. Is that clear? That means let the river do whatever it wants. If this man is swimming straight, he will always reach there in the, only with the help of his own velocity. The river ka velocity will never help him in crossing the river. So at any point of time, if you look at this velocity, he is going with v forward. The river ka velocity, I agree, it is changing, it is dragging him. But to cross this distance d, only v is responsible, velocity of the man. So time is actually the easiest one. Velocity of the river. Never helps in crossing the river. Because it is a horizontal and you need to cross the river perpendicular to it. You can just ignore the river velocity. So from here we will get, therefore time will be distance d by v man. D by v, straightforward. Is that clear? That is one. Next thing you'll also notice, let's say if this distance is some y, the y coordinate also depends only on the man ka velocity. So y coordinate is nothing but velocity of the man into t, which is vt. Agreed with that? This is the velocity of the, y coordinate of the man in the y direction. This is the first part of the question, everyone. So next thing, velocity of the river is function of y. Let's see that. So if they ask you what is the y coordinate of the man, it is v into t. So far clear, everyone? Others, keep your hands on. The next part. See, whenever you hear this word, the function is linear. So this is the meaning of it. Y is equal to mx plus c. So you can treat if velocity varies linearly. You can write this thing as velocity of the river will be some constant into y coordinate plus b. So here a and b are constants. Because here the velocity of the river is changing with y coordinate. For different y coordinates, you have different velocities. So now this you have to divide into two parts. The first part, till the middle of the river. So when the y ka value goes from 0 to d by 2. So till the middle of the river, the speed is increasing. So at y0, speed is 0. At y is equal to d by 2, speed is 0. In the second part of the river, you have to go from d by 2 to d. So there are two parts of the problem here. So substitute here, you just have to get the equation there. At y0, v river is 0. This will be a into 0 plus b. Therefore, b is 0. Great. And y is d by 2. Velocity of the river is maximum, which is u. This will be a into d by 2 plus b, but b is already 0. So a ka value is u 2u by d. That means when you're going from 0 to t by 2, the first half of the river, the velocity of the river is given by 2u by d into y coordinate. Is this making sense? This is how the velocity of the river is varying linearly when you go from 0 to d by 2. 2u by d into y. See, put y0, you get 0. Put y d by 2, you get u. It's a linear function. B is 0. The second part, y goes from d to d by 2. So you have to split the problem into two parts. You don't get a direct one equation from 0 to 2. So in this thing again, when y is d by 2, your velocity of the river was u. This is a into y plus a into d by 2 plus b. I'm just mathematical equation. There's nothing physics about this. When y is equal to d, velocity of the river is again 0. This will be a into d plus b. There we have two equations and two unknowns. So b is equal to minus ad. Take this. This is equation 1. This is equation 2. Take this and put it in equation here. You will end up with u is equal to ad by 2 minus ad. We get a is equal to minus 2u by d. And b is equal to minus 2a by d. B is equal to 2u. Take this a and substitute here. There. So in the second part of the thing, the velocity of the river will be a is minus 2u by d, y coordinate plus 2u. Is that right? Y is equal to d by 2. Yeah. Check. So this is the velocity in the second half of the river. This is the velocity in the first half of the river. This would be the complete function for the velocity of the river. So from 0 to d by 2, velocity increases, d by 2 to d, velocity decreases. So you'll get two different functions. You can't represent the whole thing with one equation. Is this clear, everyone? Again, I did nothing here. This is not physics. This is pure maths, isn't it? The equation will look in the form of ay plus b. Y is 0, v is 0. One equation. Y d by 2, v is u. Second equation. Y is d, v is u. Third equation. I just substituted all of them. I got the values of a and b for each section of the river, and I got the values. But remember this technique, quite useful. You will see this a lot of times. You will hear this. You will hear words like, you will see this in sound waves. The temperature of the gas is increasing linearly. The radius is increasing linearly. The current is increasing linearly. You will hear these words a lot of times. Whenever you hear something like that, this is the function, how it looks like. Y is equal to mx plus c, a linear function. Any doubts on this page? This is the second part of the equation. Third, equation of the trajectory. So C part, let's say. So when this man is going here, this was A, this was B. Let's say this is x-axis. This is your y-axis. So I'll take A as an origin. So this person will not go in a straight line. This guy is actually going in a curve where this vertical component in the y direction is velocity of the man. The horizontal component is the velocity of the river. Right? And since the man is swimming straight, so man is putting all his effort in y direction. So this I showed you. So y coordinate will be velocity of the man into t, which is vt, right? And that is great. Now what about the x coordinate? Now see, we know for the velocity of the river, let's do for the first section, okay? And then we will just say it is symmetrical for the second section. Between 0 to d by 2, we proved the velocity of the river is 2u by d into y. The velocity of the river is changing with y coordinate. So can I write this thing as dy by dt is equal to 2u by d into y, and then dy by y is equal to 2u by d into dt. Can I integrate this? This is wrong. Can someone tell me why this is wrong? This we proved, right? Velocity of the river is 2u by d. So this is right. इसका problem नहीं है. I can't write like this. Right हो गया. Right, Utsa.
Yeah, the velocity of the river will be dx.
Yeah, you can type your message in the chat box, Reparo. Everyone is doing the same, so please do that. We want others also to try. So the catch is this. So the velocity of the river is in which direction? It is in the x-axis direction, isn't it? So velocity of the river is not dy by dt. Velocity of the river is dx by dt. Which direction is the river? River ka velocity is along the x-axis. Since it is along x-axis, that was a mistake. You can't take it as dy by dt. Yeah, now you'll get it. So you got dx by dt is equal to 2ud by y. But I already know y coordinate is vt. I can take this and substitute here. So we get dx by dt is 2u by d and y coordinate is v into t. Integrate this. You'll get x is equal to uv by d, that will be t square by 2. 2 will cancel. This is your x coordinate. So velocity of the man was v. Check this out. That's your x coordinate and that's your y coordinate. So you got y is equal to vt and we got x is equal to uv by d into t square. So get time from here, which is y by v, and substitute here. You get x is equal to uv by d into y square by v square. You end up with x by u by dv into y square. What is this? This is a parabola. This person is actually going in a parabolic path. He's not going in a straight line. Are you clear, everyone? Check out the steps. So yeah, this is the thing you have to be careful. So first you need to find vy in terms of y coordinate. And then you know y coordinate is vt. So replace that and get time. And then you go ahead with this. Please have a look at the steps. This would be a proper advanced paragraph question. Any doubts on this? Anyone not clear with anything particular here? We'll see. It will be actually the second half also will be a parabola. We can guess from here, kind of. Equation तो वही होगा ना रे? This will become 2u y by d plus 2u. This is 2u plus t. So you'll get something plus some constant आएगा. Something like it's also a parabola. I'll show you. All clear till here? So we'll say by symmetry it looks the same, and then we can finish it off. So this trajectory, right, is looks like this. X is equal to u by v d y square. So if you try to plot this graph, this is a horizontal parabola. Look at this thing. For different values of x, you have 2 to y coordinates. So this is a horizontal parabola. This is how this equation looks like. And remember, this is the equation only up to d by 2. This is valid up to d by 2. So drift up to y d by 2 will be x coordinate. At time d by 2v, it takes time d by 2v to reach the midpoint. So the drift will be the drift up to the center will be uv by d, that's your x coordinate, into t square. And time is, or else you can keep y is equal to d by 2 here directly. U by yd and y is d by 2 ka square. I'll just keep it like this up to, so this will be u d by 4 v. This is the drift, everyone. So by the time he reaches the middle of the river, he will horizontally drift up to this distance. So let me show you how the path looks like. If you take this river, let's say starting from here A, this was B, this is your midpoint here, y is equal to d by 2. So initially, first you will go in a parabola like this. Getting it? And what we proved right now is this is the drift. So in this process of going till there, this person has covered a horizontal distance of du by 4v. So once he reaches here, again, by symmetry, now speed is decreasing. He will go like this again. So this will be this kind of a parabola. You're getting it? So we have two parabolas here. So if I actually draw the full parabola, it looks like this. This parabola and this parabola. You're getting it? So we will take the lower half of this and we'll take the upper half of this. Able to visualize? So it's like two parabolas which are just opposite to each other. And you can actually kind of guess this. So when you're leaving, what is the velocity of the river? 0, right? So this should be perpendicular. So when you're leaving from the river bank, you should leave perpendicularly because river ka velocity is 0. And when you're entering the other river bank, again you will enter perpendicularly because V river is 0. I hope you're getting it. This will be the drift. Again, by symmetry, we can always say by symmetry. Same thing happens on the upper side. You just rotate this page 180 degrees, you will see the same thing. So this will be the second drift, which is du by 4v. Because whatever happens at the bottom of the river, same thing happens on the other side. So this will be the path of the person. So when you see this from a ground or something, this is how you will think. And I know how is he swimming? So this person at every time, right? He's swimming straight only. He's always looking in front of him. But he's actually going like this. So if you try to look at his velocity of the man is constant. V man, V man, V man, V man, V man. But the river ka velocity is changing. So here ka river ka velocity is less. Here river ka velocity is more. Here ka river ka velocity is maximum. Again it decreases. Again it decreases and becomes 0. So the total drift will be just double this up. So we calculated everything for one half and we are saying by symmetry the upper half will look similar. I hope that is making sense why it is similar. Because see now, if you look at the river ka speed, whatever was happening at the bottom, the same thing happens on the other side, isn't it? It is function is increasing, function is decreasing. So by symmetry, what happens on the lower side will same thing happen on the upper side. Yeah, you can prove it mathematically, but if you can see by symmetry, it saves you time. This will be your final path. It's two different parabolas, each parabola ka piece. So this would be this parabola and this would be this parabola, half and half of it. Is this clear, everyone? In the exam, if they just ask you to draw the graph for this kind of thing, so there are a few ways to eliminate the options. So if they ask you this question, right? And if I don't want to solve and they just want the path of the person, what things I will see? First thing, when the man leaves here, velocity of the man is this, river ka velocity is 0. So he should leave perpendicularly. When he's entering the other side, again, velocity of the river is there. There's no man is there, but there's no river. Should enter perpendicularly. So I don't know how the path will look, but it should leave perpendicularly. It should enter perpendicularly. I will check that. Whichever option. So if someone draws like this, this is wrong. It should come out perpendicularly out of this. So that way I can eliminate one or two options. And second thing, center of the river is flowing the fastest. That means as the man goes to the center of the river, it should become more and more closer to the river, isn't it? Is that making sense? That much I can guess. You can see as you're going straight, this is V. This vector is increasing. This vector is increasing. So this angle becomes smaller and smaller, isn't it? So you'll become closer and closer to this. Similarly, when you're going away, again, this vector should increase. So kind of you can guess the trajectory though. That much so you can guess, but yeah. This is how you solve. Any doubts on this? It's a pretty good question. Should definitely try it again on your own once more. So the first part of the question, this was the easiest stuff. You just cross the river with your own speed, so forget the river ka velocity, d by v. Second thing, it is a more of a mathematical thing. It's a linear function, so it looks like ay plus b. I found the equations by putting y is equal to 0, y is equal to d by 2, and so on. Then the third part, I got the y coordinate from the Manka speed. The x coordinate I have to integrate because it is increasing. I got x coordinate and y coordinate. I eliminated time. I got the equation of trajectory, which turned out to be a parabola. You wanted drift. Drift occurs, up to center. That is y is d by 2. The drift will be when y is d by 2. So put y is equal to d by 2 here. That will give you the x coordinate, which is the drift. So and you're done. So this is how the trajectory looks. And by symmetry, we can say whatever happens in the lower half, same thing happens in the upper half. Any doubts on this? So in river problems, this is there one type of equation where the river velocity is not uniform everywhere. All clear with this? Any doubts? Anyone not clear with anything? Anyone got the equation of trajectory? Didn't reach till there. Did you guys figure out the equation? At least this part you figured out? The velocity as function of y. This is important. This much you should have figured it out. Okay, it's okay if you couldn't figure out, but now you know. So next time when you see something like this, you know what to do. Again, I'm telling you, you really want to learn this problem? Tomorrow or day after tomorrow, take a rough paper, see the question and try to solve. Trust me, you will forget. Most of the time, most of the people can't do it. And that's completely fine. Struggle a bit, 4 or 5 minutes, just struggle, think what is there, what did I teach you, try to remember. You won't remember, that is fair enough. Come back. Let's say if you got stuck here, just see only this part, then again go back. Again, struggle for another 2-3 minutes. If you got it, great. If you don't get it, then see the third part. Like that. That is how you do. Maybe the whole process might take 10 to 12 minutes of struggling. But trust me, once you finish at the end of the day, you will actually understand what you did. So I'm telling you again, if you just flip the pages without understanding, right, you will feel like, huh, I read the notes, so I know everything. Exam mein nothing will come out of the head. This is a thing you guys need to really understand this and accept the fact. Just because I read something, I saw something doesn't mean you know. You should have done it on your own. Trust me on this. It's not only for JE or anything. Tomorrow, no matter what you start, whatever skill that you're trying to learn, you want to start your own startup, until unless you be there and you do the work, it is not going to happen. Unfortunately, your schools may have taught you something wrong. Without putting too much effort, even if I study like 3-4 days or 1 week before, I'll get good scores. So that was an illusion. So forget about what happened in school. You want to start a YouTube channel, you want to get million subscribers, you need to put 2 to 3 years of work. Until unless you're already a big celebrity. Right? You want to learn dance, it is going to take 4 to 5 months if you're a beginner for minimum basic steps. You want to learn a musical instrument, it will take 6-7 months minimum. I'm pretty sure people who have learned a musical instrument or something, did you learn it in first 3 days? You must be playing horribly. I tried learning violin like that. I tried actually 2 times. First time I couldn't get time. Second time I learned till Twinkle Twinkle Little Star. And then I got busy with classes. I dropped it. I had to learn again. So the teacher told me, Arun, practice every day for 15 minutes. Zyada nahi hai. So I used to close my door, everything sealed. Then I used to practice in my room. I used to feel like the violin is crying. When I used to play, I used to feel so bad about it. I used to feel like, violin is telling me, Arun, why are you harassing me? Like, what is this? What kind of play you're doing? It used to sound that horrible. I used to play for 10-15 minutes. I myself used to feel depressed and keep it away. Now, ye dekho na, overconfidence. I was like, yeah, I used to think there's something wrong with the violin. That's why it is not coming properly. So after 2 days, we used to have a class every weekly, 2 classes of 1 hour each. So the teacher there, I went to him. Then I told him, sir, there is some problem with the violin because when I'm practicing, it is sounding horrible. He said, okay, let me see. He took it. He played it. Yeah, he played it so beautifully. Yeah. I felt like, yeah, बहुत अच्छा हो रहा है. And then I realized I'm the idiot here. Getting it? The violin was never the problem. I am the one who is unskilled. I don't know how to play. It was sounding so horribly. It really felt like violin is crying. Getting it? So happens. It took me almost, I think, 2 months. I'm not that smart like you guys. So it took me 2 months. I struggled. I practiced like maybe not much, 15-20 minutes per day. Finally, I could play Twinkle Twinkle Little Star. When I was playing, it was sounding like Twinkle Twinkle Little Star. Right, yeah. And then again, I got busy with work. So I'll try again, maybe next year or something. The plan was there. So, and trust me when I say this, you really want to learn something, behave like a beginner, understand there are a lot of things to do. You need to give time. So don't worry about rushing and finishing off a lot of things. Unfortunately, currently, right, our world and the society or everything, right? People always think like this. You need to do a lot and you need to do fast. You can't do a lot, you can't do fast. If you do that, you will mess up everything. You will not learn anything properly. To keep the philosophy simple, do less, but do it properly. Understand why you're doing and what you're doing. And trust me, short term में maybe result नहीं आएगा, but long term में you will go way ahead of many people. People come and tell me, sir, I finished Cengage 300 questions in 5 days. They're very proud of the fact. You take out that book and ask them 5 questions from that, half of them they can't answer. Ah, sir, this question, nah, I forgot. Oh, this question, I don't remember what I did. So be careful with that. Again, I'm not telling you like a teacher. Take it from a person who lived double your age. Kidding it. I have seen this. I have seen this multiple times on and off. I have seen, brilliant people doing nothing in life. Because, brilliant people ka problem kya hai na? If you're a genius, the problem is in life, you never had any issues. Everything that you tried, you got it on the first attempt. That is a problem with genius people. So the day when you have a problem, right, the genius people don't know how to handle it. But if you're a dumb person, right, like me, who doesn't get things immediately on the first try, so what will happen for me? If you give me an easy problem or moderate problem, I will struggle for 1 or 2 attempts, then I'll get it. When you give me a hard problem, I still don't realize it is hard. So I will still struggle 4 or 5 times. I'll still get it because I'm used to it now. Because mujhe pata tha, I'm not going to get it, so I will try my best. But a genius person, you give him easy and moderate, he will get it on the first attempt. When it is a hard question, he needs to try 2 to 3 times. He will try once, he will try twice and say, hey, what the hell is this? There is something wrong with the question. He will not do it. And that is a problem with genius people. Because they never had they never had to work hard or try hard to do the problems. Keep this in mind. I have seen genius people, whom I thought will get 200 rank, 100 rank, ended up at 20,000, 25,000 ranks. People whom I thought, like, ठीक है, बच्चा sincere है, but इतना smart नहीं है, ended up at 500 rank, 400 ranks. Every year there is someone who surprises me like this. Even last year there was one kid who I was expecting around 2 years back, 2022 batch. I was expecting around 2,000 rank. This guy scored 400 something. That guy was pretty sincere. And then in the same batch, there is one kid who I thought will get 200 in the beginning of 11th standard. By the end, this guy completely strayed from his path. He got so obsessed about thinking about others. What was his biggest complaint? I and my friend, we both used to be in the same school. I'm a topper. He used to be second. Now, when we are preparing for 11th and 12th, he's getting more marks than me. I said, "ठीक है ना, let him get more marks. Now, what is the problem?" No, sir, how can that be? I'm also putting more work. The problem was that the person B, right? He never cared about person A. He just kept his mouth shut. He kept working on himself. This person A, right, is always obsessed. My friends are getting more than me. My friends are getting more than me. अरे let him get ना रे चलो तेरा friend को first rank आ गया रे let him get all India first rank. If you got a rank which is sufficient to go to IIT Bombay, your favorite branch or whatever branch you're okay with, are you not happy with that? So what others do is none of your business. Keep this in mind. Getting it. See, we have done almost how many problems? This is 69. There are 70 problems almost in kinematics notes only. If I ask you something from the notes, are you confident you can answer without hesitating? That should be the first priority. Then choose 1 or 2 materials and do them properly. Trust me, you learn physics like that. Within 6, 7 months, you'll love the subject. You'll be way ahead of many people. Don't get obsessed with solving 300, 400 questions. Take 1 or 2 books, do them thoroughly. Do once, do twice. Be very clear why you're doing a question, what you're doing in the question. Why am I thinking like this? Ask yourself. That is the right way to do. Let's go ahead. So that is thing about the relative motion. The next thing is flat problems. You can see I show you a lot of varieties, different stuff. So it does cover. The notes itself will be a big thing. By the time we finish all the portion, you'll have almost around 1300 to 1400 problems. That's your biggest revision material. What are these flag problems? Did you ever sat on a scooty or something with your flag or a cloth? So if you sit on a scooty and put a flag, how does the flag, go? Opposite to the vehicle, isn't it? So let's see. So consider a flag on a vehicle. Case one, let's say wind is blowing. And let's keep the vehicle at rest. So if you take a flag, if the wind is blowing, the flag also will point in the direction of the wind. Simple. The same thing, you can also do for some smoke also. Let's say you have a chimney or something, and let's say a smoke is coming out. Just give me a minute. Someone is knocking the doors. Yeah. So let's say there is a smoke coming out of a chimney and the wind is blowing. Same story. The smoke goes in the direction of the wind. So they can ask questions like this also. There is a ship, steamer ship is going and the smoke is going in so and so direction. What is the speed of the ship? We'll see. I'll show you this. So this is one of the technique, right? They used to use in World War II when two ships are fighting. They didn't have any radars and everything. And most of the ships are, based on steam and everything. So if I know which way the wind is blowing and I know which way the smoke is going, from there I can figure out what is the velocity of the ships. And accordingly, I can estimate the position where they're going to be and I can fire. Anyway, so this is the first part. So if there is a wind blowing and if you keep a flag, the flag will point in the direction of the wind. Clear with this? Case two. You take the flag and sit on a vehicle. Let's say there is no wind is blowing, there's no wind, and a vehicle is moving. So let's say we have a vehicle and we have a flag. So if the vehicle goes forward with you, then the flag points backward. The same thing you can say about the steam machine, in this thing also, smoke. Let's say we got a ship and this is emitting smoke here. So if this goes with you, the smoke goes backward. So you can call them, flag problems or, chimney and smoke problems and stuff. Everyone got the idea? That's it. That is a concept there. If the wind blows, the flag will go in the direction of the wind. If the vehicle goes, it goes opposite to the vehicle. Let's see a question. Let's say a vehicle moves east with 10 meters per second. And the wind blows northeast with 10√2 meters per second. So both are happening at the same time. In which direction does the flag point? These are straightforward mains level questions. Nere param. Right, Shreyansh. We have one answer. So this is north, this is east, west and south. Nere Ishman. This answer is a good one. Param got it. Ishvi, no. Aditi, no. Samyak, yes. See, listen. So there are two parts of the problem. First thing, the wind is blowing northeast. Vehicle moves east. Now you tell me, if the vehicle is moving east, the flag will point which way? West. So the flag will point 10 meters per second backward. Right? West, this is due to the vehicle. So if the vehicle goes towards east, the flag will point west. Next thing, the wind is blowing northeast at 10√2. So the flag will point in the direction of the wind, 10√2 meters per second. So you will be in the direction of the wind. So this is due to wind. So the flag will think these are the two components, isn't it? You need to get the resultant of these two vectors. So northeast meaning this is 45 degrees. So if you resolve this into components, we will get 10 and this will be 10. I'll just write it again here. So if you resolve the components, the wind will be 10 upward, 10 horizontal, and this guy is 10. So horizontal 10, 10 will cancel. Yeah, you're just left with 10 in the upward direction. Therefore, flag points north. Making sense? Just vector resolutions, और कुछ नहीं है. So you put a vector opposite to velocity and put a vector in the direction of the wind and get the resultant of this. Any doubts on this? Easy? Let's see one more. Any doubts on this? Please ask. The same thing I can do with the flag also. मतलब a ship is going and I can talk like that. Next one. So we have a boat. A boat moves north with 10 meters per second in a river flowing east with 20 meters per second. The wind is blowing southwest. (10√2 meters per second). In which direction does the flag point? There are three things here. I'll give you an idea. Say, so we have a river which is flowing from west to east. This is the river. Your boat is going north, like this, 10 meters per second. Your wind is blowing southwest. The wind is blowing like this. Do you get it? So three things are happening. Now what? That's not the answer, Ishman. Nee, Param, not the answer. Did you get the whole story? So boat is going perpendicular to the river. River is flowing to this thing. That means this boat won't go straight. The boat will actually drift. But that is okay. We don't care about that. We're just interested in the flat car direction. Boat moves north with respect to river. Let me add that. With respect to river. In a river flowing east. It's like a man who is swimming from A to B, but the river will drag you horizontally. East, you don't get a good answer, right? Think, take a minute. Right, Samyak. Any other answer? Right, Ovia. But can you tell me direction? What? South, west, east, north? कुछ तो होता है ना? Right, Shreyansh. So listen, three things. Let's take one at a time. If the boat is going north, flag will point which way? South. So 10 meter per second. This is due to the boat. If the river is flowing east, then the flag will point west. Think of like this. If the boat is not traveling, if you just put something in a river, it will go with the river speed. Right, Ovia. Right, Param. But you didn't tell me the angle, right? Let's see. So this guy will be 20 meter per second. This is due to the river. The wind is blowing southwest, so this is due to wind. All three are in the same direction actually. This is 45 degrees. There. Resolve them into components. So we get 20. This will be 10. This will be 10, and this will be 10. That will be the three components there. So we have 30 meter per second to the west and 20 meter per second to the south. So the flag will point in this direction. You can choose anything as theta. I will take this as theta. So tan theta is opposite side 20 by 30. 2 by 3. So how do you talk about this angle? So theta here is tan inverse 2 by 3. So listen, how to say this thing angle. So it is written like this. The flag points theta, that is tan inverse 2 by 3 south of west. I'll tell you how to write that. See, that will be your final answer. So options will be like this. Or you can also write, you can take the other angle as alpha, which will be tan inverse 3 by 2 west of south. That is also the same thing. So what is this representation here? Let me show you that. But everyone clear with this? Any doubts on this?
Sir, I had one question. Why did we take the velocity of river in the opposite direction?
Let's say if I give you a flag and throw you in the river, you will go with the river.
Oh yeah, then the flag will
And the
point.
flag will point opposite to the river.
Okay. I realized it.
Always, whenever you have a doubt, you jump yourself. You will immediately realize. Clear? So look at this thing here. If someone tells you like this, 30 degrees north of east. Again, understand the word of this. From east, you have to rotate 30 degrees north of east, meaning this is the east. So from east, the vector is 30 degrees towards the north side. You getting the meaning of this? So from east, rotate 30 degrees towards north. That is the meaning of the statement. So if I say 60 degrees west of south, can you tell me how that looks? So from south, go towards west, 60 degrees. Means rotate towards west ka direction 60 degrees. That will be your vector. Are you able to get the meaning of this? Let's see one last one. Let's say if I say 20 degrees north of west. So west direction say you need to go 20 degrees towards the north. So means you rotate like this. All are clear with this? That is the meaning of this. So the meaning of this is from west, rotate 20 degrees towards north. That is how you read that statement as. So if you don't get a standard angles right, southeast, northeast, sometimes you get answers like this. So you need to know how to write the options. All clear with the flag problems? That's it. The concept is a small concept, but that's what you do with flags. Any other doubts on this? All clear with the relative motion. So that is the complete relative motion ka part. So we have seen, particles chasing problem, cat and dog problems, minimum distance between two particle problems. Those are the three main models there. Then we did Rainman, then we said rubber board, then we saw flag. So there are like something like 6 to 7 varieties there. The last part in kinematics is graphs. Graphs are quite important, not only in kinematics, but you will keep seeing these graphs everywhere. But let's see in kinematics what happens. So in every graph, primarily, right, at least in physics, we have only two quantities in graphs. So whenever you have a graph, the first thing in a graph, we have a slope. Which is nothing but dy by dx. The second quantity you have in any graphs, the area under the curve, which is an integral y dx. That's it. So generally in physics, whenever they give you the graph, these are the two quantities you can check. What is the slope? What is the area? Almost 80 to 90% questions will be based on only these two quantities. 10-20% there are varieties where you can ask, but these are the primary things. So in kinematics, luckily, we really don't have too many things. We have only position, we have velocity, we have time, and we have acceleration. We have only 4 variables. So we'll play with these 4 variables in our graphs. So first we'll see standard graphs, and next class we will see non-standard graphs also. So first let's see some standard graphs. The first graph is position time graph. Like I said, concept is pretty easy. The main thing is to see the variations. So whenever someone gives you a position time graph, x coordinate versus t. So if this is a graph, so in a position time graph, what does slope give you? Slope is x ka y ka place mein you have x, and x ka place mein you have time, dx by dt. This is nothing but velocity. So if someone gives you a position time graph, slope at a point gives you velocity at a point. Is that clear, everyone? Slope at any particular point gives you velocity at that point. Great. What is the second quantity? Area. What is area under xt graph? Integral x into t. What is position into time? Nothing. There is no meaning here. There, like I said, in every graph, there are two quantities you can study, but doesn't mean it should mean something. So in a position time graph, the only important quantity is slope. The area means nothing. Clear with this? So let me show you something. Suppose if someone gives you a graph like this. Let's say this is 60 degrees, this is 30 degrees, and this becomes flat. Let's say this is 2 seconds, this is 4 seconds. Can you tell me what is this graph trying to tell you? So this is one important thing. You get theoretical questions. Looking at a graph, you should be able to tell what is happening. What is the situation here? So look at this thing. I'll help you with one. So here, where is the particle starting from? At t0, where is the particle? At origin.
Yes,
So
sir.
particle starts from origin. That is how you start. So initially, what is the slope? Tan 60. So particle starts from origin with speed tan 60, which is √3 meters per second. For 2 seconds. So it does this for 2 seconds. Then for some reason, the speed changed. Then the slope became tan 30. Then it goes with 1 by √3 meters per second till 4 seconds. Then the slope has become 0. Then it stops. Are you getting how to interpret that graph? So you have a block there, which is going with the speed of √3 for the first 2 seconds, then 1 by √3 for the next 2 seconds, and then finally stops at 4 seconds and doesn't move from there. Is this understood? So if I give you a graph like this is how you can interpret. All clear with this? Now let's see then. I'll give you one like this. You try to interpret the graph. Understand, this is a graph. This is not the path of a particle. For example, say, I'll tell you one more thing. Let's say you're standing here. Let's say if you're going like this, let's say you go 1 meter to the front, then you come back, then you go back, you come back, you keep jumping like this, front and back, front and back. How will your graph look like? You go from x is equal to 0 to x is equal to 1, then you come back to x is equal to 0, then you go to x is equal to -1, then you come back to 0, 1, 0, -1, like this. If I ask you to draw the graph, how will you draw the graph? So you are at, first of all, x is equal to 0 to 1, so x is equal to 1, then you come back to 0, then you go to -1, then you go back to 0, then you go to 1. You're getting how the graph looks like a step function. This is the graph. This is not how the person is moving. The person is not jumping up and down. Are you getting this? So be careful. Graph is not the path of the particle. The person is simply going front, back, back, front, front, back, back, front, and so on. But the graph looks like this, a step function. I hope you're getting. Graph is different from the path. Okay. So that simple thing. Let's say this is x is equal to 10, x is equal to -5, and this is 45 degrees. Can you describe the motion? Can you describe the motion? And this is the time when it stops. Find the time. Or let me just call it T0. Describe the motion and find T0. Okay, right, Ishman. Right, Srishi. Right, near Hari, that is wrong. Right, Shriyansh. Utsa, that is right. Param, that is right. So what is happening here? There's a little bit of a geometry. So here the particle starts from x is equal to 10. Right? If you look at this, that is 45 degrees with what speed? Remember, the slope should be always measured with the positive x-axis, 135 degrees. Right? Moving backward with 1 meter per second. Or you can say moving towards negative x-axis. It is not going front, it is going back. That is the meaning of minus 1 meter per second. Till x is equal to minus 5 and stops. So if I have to draw a picture now, the picture will look like this. X is equal to 0 here. This is x is equal to 10. This body is going backwards 1 meter per second. This is the scene at t is 0. This block will travel till x is equal to minus 5. Then it stops here. This is how the picture would look. The body is actually going backward. And what is that time? If that is 45, this also will be 45. You can just use geometry here. What will be this angle here total? This is 15, na? And this is 45, right? So this also must be 15, right? So you just make a triangle there. You will clearly see. If I just draw that line, this is 10. This is minus 5. That means this length is 15. This is 45. So this is also 15. Therefore, T naught is 15 seconds. So that means this body will stop at 15 seconds. All got this? Easy to see, right? Let's make it a little more complex. Let's say we have an xt graph like this. Like this. It is getting closer and closer to the time x this thing, but it will never touch it. It will get closer and closer like this. Let's say this is x is equal to 10. So tell me what is happening to the speed and acceleration. Describe velocity and acceleration. So exam you'll get theoretical questions like this. They'll give 4 options. Options will be like this. Velocity is increasing, acceleration is increasing. Velocity is decreasing, acceleration is decreasing. Velocity is decreasing, A is increasing. Both are increasing. Yes, I can make 4 options. You're getting? A increases, V increases, A decreases, V decreases, then A decreases, V increases, and so on. But let's try to describe the whole thing. Describe the velocity and acceleration for this. Can you give me the directions also? Give me the 2 things. Tell me whether the magnitude is increasing or decreasing, and also tell me the directions of velocity. Is it positive x-axis or negative x-axis? I want both. The direction of velocity, direction of acceleration, and how is the magnitude of velocity and magnitude of acceleration changing? Are they increasing or decreasing? I want 2 data points, direction and how does the magnitude vary? Think. Take a minute. It's a good one. They ask questions like this. Okay, acceleration is a good one. Velocity is fine, manageable. Acceleration is the main one. No, Shreyans, when I say negative, I want direction. Think. Take a minute. Don't worry about answering. I'll show you. Think for a minute. Focus on getting it. And just show you can verify. I think I should make an option. Everyone can only type one time the answer.
To say the magnitude or describe the magnitude of velocity and acceleration.
Don't.
Okay.
Meaning you have to tell me something like this. Velocity is pointing forward and decreasing in magnitude. Yes, our options.
Okay.
Velocity is pointing forward and velocity magnitude is increasing. let me help you with this. I'll ask you one more, then you can try. I think some of you did get it. So first thing in an XT graph, what is velocity? Slope. So if you try to draw the tangents here, tangent, 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 you can see something here. It's becoming more flattish. So for convenience, what will I do now? I'll take some numbers. Let's say here the number is minus 20, the slope. Again, not true. I'm just taking some random numbers. Here the number is minus 10. Here the number is minus 5. Here the number is minus 3. Here the number is minus 2, minus 1, minus 0.8, minus 0.7, minus 0.6. You can see what is happening. As it is getting flatter and flatter, the slope is getting closer to closer and 0, but it will never be 0. So if you look at the tangents here, the slopes are obtuse angles here. So you can clearly see slope is negative and decreasing in magnitude. But never gets to 0. Getting closer to 0, but it will never touch 0. Now replace the word slope with velocity, meaning the velocity is backward. It is slowing down. You getting it? So this is how the picture looks. This is your origin, x is equal to 0. The block is starting from x is equal to 10. The velocity is backward. As it gets closer and closer to the origin, it will slow down, slow down, slow down, but it will never reach the origin. So body moves in the negative x-axis direction. Body moves towards origin. Because you'll never touch that, x will never become 0. With the decreasing speed, right, but never reaches origin. As you get closer and closer to the origin, your speed is becoming negligible. Now you tell me, if the speed is decreasing, then acceleration will be which way? Acceleration must be on the right hand side, no? Isn't it? If your speed is decreasing, that means acceleration is pulling you backward. And what about the magnitude of acceleration? Look at here. What is acceleration? Change in velocity by time. Look at the change in slope here. What is the change in slope here? 20 minus 10, 10. What is the change in slope here? 10 minus 5, 5 minus 3, 3 minus 2, 2. Did you notice something? The difference is becoming smaller and smaller. The delta V, the change in velocity, is becoming smaller and smaller and smaller. That means as you're going left towards the origin, the acceleration is also decreasing in magnitude. So acceleration is along positive x-axis. Because speed is decreasing, acceleration is opposite to velocity. That is positive x-axis. And the magnitude of acceleration is also decreasing. So as you get closer and closer to the origin, the acceleration is becoming smaller and smaller. Velocity is also becoming smaller and smaller, but it will never become 0. So at infinity, eventually it will stop. Is this making sense? So A is positive x-axis, decreasing. Velocity is negative x-axis, decreasing. That would be an option. All clear with this? How to interpret that one graph? So they can ask a lot of good theoretical questions. If it's a more than one choice question, no, options will be like this. The particle is always going towards the origin, but never reaches origin. That will be one of the option, right? The velocity is decreasing in magnitude and it is pointing backward. The acceleration is positive and it is in the positive x-axis direction. Getting it? As it gets closer and closer to the origin, the acceleration decreases. So I can ask a lot of stuff. All clear with this? Take a break. Come back by 9:41. We'll continue from here. Any doubts so far? Any doubts so far? Go take a 5-minute break and come back. Let's see the next one. Let me give you one more similar thing. You guys try to answer this. Again, gets closer and closer to this line, but it'll never touch. Describe velocity and acceleration. So XT graphs, right? They look simple, but they're one of the things they can ask a lot of theoretical questions. Chalo, other scams on. Let's get this thing. Same thing. I just changed the shape a bit. Try. You got a minute. I think most of you. Nee, Advai, that is wrong. Aditi, tell about acceleration also, no? Acceleration is not increasing, right, Atrishi? That is right, Ishpan. You need to tell about acceleration also, Utsa. Right, Samyak. Velocity near हो गया. Slope decrease हो रहा है ना? If you draw tangents, look at this, it's becoming flat. Near, Param, that word is wrong. Velocity away from origin is wrong. It is actually towards the origin for some time and then away from origin. That wording is wrong. Right, Shyamsh. Let's see. Yeah, that is okay, Aditi. Magnitude is decreasing. Look at this thing. First, draw the tangents. So if you draw the tangent here, this will be the tangent here. This will be the tangent here. This will be the tangent. Can you see what is happening? The line is becoming flattish. Again, let's put some numbers for convenience. It's all acute angles. So I will say I'll put plus 20, plus 10. Again, I am just putting some random numbers. This is 5. This is 3. This is 2. This is 1. This is 0.9. This is 0.8. This is 0.75 and so on. You can see as you get closer and closer, the numbers become smaller and smaller and they get close to 0. Make sense? So how is this body traveling? If I try to draw a picture here, the block is starting from x is equal to -5. This is the origin. You're trying to get closer to x is equal to 10. Param, here, see, this is the thing that wording will be a mistake. So initially the velocity is towards the origin, isn't it? Once you cross the origin, it is away from origin. So that won't be the right wording. You should say velocity is forward and decreasing in magnitude. So the velocity is forward And can someone tell me anything about the acceleration? What is happening to the speed? Speed is increasing or decreasing? Speed is decreasing, so acceleration must be backward. And the acceleration is also decreasing because look at the numbers. Difference is 10, 5, 2, 1. The difference is becoming smaller and smaller and smaller. There. So the velocity is towards x is equal to 10. Velocity is positive and decreasing. Acceleration is negative and decreasing. And it is going towards x is equal to 10, but it will never reach there. All clear with this? Any doubts on this? Got it? Let's see one more. Yeah, that's a little bit about x-t graphs. You can play like this. Same thing, I can ask you in another way. X is equal to a into 1 e power minus bt. A and b are constants. Plot x-t graph. Reverse, I can give you a function and ask you this thing. This x is your x coordinate. E is your exponential, that E is the number 2.713 and all that stuff. So when you get something like this, right, always start with some values. Put t0 and check what happens. At t0, you will get x is equal to a into 1 e power 0, which is 0. You're starting from origin. If you put a t infinity large value, so you get x is equal to a into 1 e power minus infinity, which is 1 by e power infinity. E power infinity is also infinity, 1 by infinity. So what is 1 by large number? 0. So this thing comes out to be a. So that means this body, right, it is starting from origin and it is trying to get closer and closer to a, but it will never reach a. That is the meaning of infinity. You'll never reach infinity. So this particle starts here and gets closer and closer to this point. It gets closer and closer to this line, but it will never reach. So this thing is actually kind of like question C, isn't it? The only difference is question C is starting from 5. This guy is starting from origin. Yeah. So we have a block here starting at x is equal to 0. It is getting closer and closer to x is equal to a. So velocity is forward, acceleration is backwards. Same story as the previous question. All clear with this? Now, just to give you a little idea about this e power x ka graphs. So this is how the graphs will look like. If someone asks you to draw y is equal to e power x, the graph looks like this. This point is when x is equal to 0, y is equal to 1. This is y is equal to e power x graph. The function is just increasing. At x is equal to minus infinity, y will tend to 0. So x ka value goes to minus infinity, y becomes closer and closer to 0. If someone asks you to draw y is equal to e power minus x graph, it will be a reverse of it. So just have an idea about these graphs, because e power x graphs, they will come a lot in 12th. But for now, this much you should have an idea of how does an e power x look like. All clear with this? Let's see one more easy one. Any doubts on the 72? Can you draw VT graph for this? I know I didn't teach you VT graph, but can you draw VT graph and AT graph? You know this from calculus, dx by dt is velocity. I think just draw VT graph sufficient. AT graph looks similar actually. These graphs are quite common. You will see this thing in later on air resistance. So for VT graph, what to do? Just differentiate this function here. So V is dx by dt. That would be a into 1 ka differential is 0. E power minus bt ka differential will be plus b e power minus bt. E power something. So the minus bt comes out and so V is equal to AB into a power minus bt. So if you try to plot a VT graph for this, when t is 0, velocity is AB. There, this is how the graph looks like. It's a decreasing function. It gets closer and closer to velocity 0 at infinity. Yeah, it will never remain constant. It will decrease. It's an e power minus bt graph, meaning this graph which I was saying, this part of the graph. Easy? So just differentiate it and you get it. All clear with this? So I can give you functions, I can ask you to draw graphs. I can give you graphs and I can ask you what is the situation. We can play both the ways. Let's see one more. This is an xt graph. Let this be A, let this be B, let this be C, let this be D, and let this be E. So in which section of the graph or in which region of the graph, the particle is speeding up and particle is speeding down? Options will be A, B, B, C, C, D, D. बस ऐसा 4 options होगा. Remember speeding up and speeding down? In which region particle is? They can even ask you in which region the acceleration is positive and which region acceleration is negative. This is an easy one. Get it? Okay, B to C, D to C, right, Param, right, Samya. You just need to look at the slopes. So when you go from A to B, the slope is positive slope. And what is happening to slope? At the highest point, slope is 0. Here, slope is negative. Here, slope is negative. Here, slope is 0. Here, slope is positive. So you can clearly see when you go from A to B, slope is going from 0 to positive. From A to B, slope decreases. In XT graph, slope is velocity. So therefore, V decreases. It is speeding down. Similarly, when you go from B to C, slope goes from 0 to negative. The slope is decreasing more. But it is actually decreasing, but the magnitude is increasing. So we have to be careful with the signs here because I said speeding up and speeding down. No? Slope decreases. So let me write like this. Let's not worry about the direction. Slope decreases. Slope is positive. Better, let me write like this. And decreasing. So the numbers are like positive numbers are decreasing. Therefore, speed decreases. The negative slope indicates direction. From B to C, slope is negative, means the particle is going backward and increasing in magnitude. It's going from 0 to a negative number. Speed increases in negative direction. It's going backward with increasing speed. C to D, again, the slope is going from negative to 0. Slope is negative and decreasing, means it is going backward, but it is slowing down. So for the speed, you just should take the magnitude. Is the numbers increasing or decreasing? The sign doesn't matter. The sign simply tells you whether you're going front or back. Speed decreases while going in negative x-axis. It is still going in x-axis, but the speed is decreasing. D to E, your slope is increasing again. Now you started going forward and speed increases. There, so the interpretation of the graphs is important. So the answer for this thing will be BC and D. Clear with this? So this particle, you know how it is traveling? It started from the origin, x is equal to 0. This is point A. Then it started going front, but with a decreasing speed. So it goes, slows down. It stops at B. Then it takes a turn, right? And then it started coming back to the origin. So C is also here only at x is equal to 0. Then it started going back, x coordinate became negative. It stopped here at D. Then it took a turn. Then it came here, again came back to B. So basically A, E, and C, all three are at the origin only. Are you getting it? So if you ask the motion of the particle, it is simply going like this. It's going front and back, front and back, front and back. It is just oscillating there. It's like a pendulum. This is a good example of a pendulum. If you look at a pendulum, this is how the pendulum goes. You tell me when the pendulum is going from here to here, is it speeding down or speed is increasing or decreasing? Speed decreases. While it is coming back, speed increases. While going to the left, speed decreases. And while coming back again, speed increases, isn't it? This is like a pendulum. So this is A to B, B to C. C to D and D to E. So this would be like a pendulum. So C to B are increasing and D to E are increasing. Clear with this? Let's see one more. Others can solve. This graph now. There, it looks something like this. This is point A. If you draw a tangent here, this is angle theta. If you draw a tangent here, this angle is theta. Theta is 120 degrees. This is point B. This is point C. So at this point, time is 10 seconds, and at this point, time is 20 seconds. So this is some weird curve. You can see how the curve is. At point A, the slope is making 10 degrees. At point B, the slope is also 120 degrees. This point here is x is equal to 10. This point here, x is equal to minus 10. So this is an xt graph. Questions. Particle goes from A to B like this. Find the average velocity from A to B. Find average velocity and average acceleration from A to B. Get this. Find the average velocity and the average acceleration from A to B. Again, go back to the definition. What is average velocity? Displacement by time. What is average acceleration? Change in velocity by time. Give me both the answers together, na? Give me both the answers together. Try, I'll give you a minute. Nere param. Right somewhere. Shri Hari, I think you goofed up there. First part is messed up. Right, Shriyansh.
Sir, is the first one wrong or the second one?
Get both of them. Now try again. Exam में whom will you ask? I won't be there to ask. You have to figure out. So the second one is wrong. Once you realize, you will laugh. Let's see. Average velocity. Definition of average velocity. The final coordinate minus initial coordinate by time. What is the final coordinate? Minus 10. What is the initial coordinate? 10. Time, 20 seconds. So minus 1 meter per second. Isn't it? What is average acceleration? change in velocity by time. V final minus V initial by time. What is in xt graph? What is velocity? Slope. So what is V final? Tan 120. What is V initial? Tan 120. Time 20 seconds. 0. Isn't it? In an xt graph, what is slope? Velocity. What is the slope at point A? Tan theta. At B, what is the slope? Tan theta. Initial velocity, final velocity are same. So what is the acceleration? 0. The average acceleration is 0. Instantaneous acceleration is not 0. Are you clear with this? Easy? That's a bit about xt graph. You can see how extensively we can do xt graph. So if you understood xt graphs, the remaining graph, the ideas are same. Out of all, xt graph, gives you a feeling as if it has very less data actually. But you can interpret a lot of things from xt graph. Any doubts on this? Now let's see all the remaining graphs at one go, and then we can do more problems on it. So if you take a velocity time graph, like I said, in every graph, there are two important data points, the slope and the area. So in that sense, VT graph is one of the more useful graph. It has more important information. So if you take a VT graph, the slope is dv by dt. So in a VT graph, the slope gives you acceleration. The area gives you integral v bar dt. Remember, v bar dt gives you displacement. So VT graph, you have both the things have an meaning, area and the slope. But here you have to be careful about one thing. Suppose if you have a VT graph going below the time axis. So the area above the time axis is a positive area. V is positive, time is also positive. Time is always positive. If the graph is below the time axis, it is a negative area. So the sign convention, so area above positive time axis. You should take it as positive area. Let's say if you got number 100, meaning it went plus 100 meters forward. If you got below negative minus 50, means it went 50 meters backward. So area below time axis. Is negative. So if someone asks you to find displacement, you can just take the positive area, subtract the negative area. If I say negative area, people will start thinking negative. It means you have to subtract that area. I'll just put mod so that you don't get confused. Last time when I wrote like without a mod, they made this minus into minus, they made it plus and they messed up the whole answer. So I'll just keep it mod just in case. If someone asks you for distance traveled, it doesn't matter whether you go front or back. So you add both the areas. You just want the magnitudes. The name is negative area. Getting it? Are you clear with this? So if you got area positive 100 means you went forward. Negative 100 means you went backward. That is the meaning of it. The distance traveled will be 100 plus 100. Displacement will be 100 minus 100. Clear with this? So in a VT graph, the slope and area both have a meaning. Next thing. Okay, let's do one question on this, then we'll go ahead. So we have a VT graph. This is 10 meter per second. This is 10 seconds. This is 20 seconds. Find displacement and distance in 25 Find displacement in 15 seconds. Find distance in 25 seconds. Find the time when the displacement becomes 0. Three equations. Let's get this. And we have some numbers. Try. 2 minutes, then I'll show you the whole thing. Get them. You just have to find the areas up to 15 seconds, meaning it will be somewhere here. So I'm asking this area. 25 will be somewhere here. So this area and this area. And find time when displacement is 0. Graphs are important. They will keep coming in every chapter. That looks right, Samyak. Anyone else? All three answers. Let's say it is just geometry there. I'll just draw a little big. So first of all, this is 10 meter per second. This is also 10. This is 20, meaning this angle is 45 degrees. This angle is also 45 degrees. So you want this area here. That will just square 10 into 10. The area is 100. You want up to 15 seconds here. So this is a small trapezium here. So you got a trapezium here whose base is 5. This is 10 and this will be 5. You know what is the area of a trapezium? Half base into the sum of the thing there. So this area will be half into 10 plus 5 into 5. How much is that? 15 by 75, 37.5. So this area is 37.5. So what's the displacement? Just add them up. 137.5 meters. Easy?
So could you go to the previous slide?
Hmm.
So, but oh, nothing. No,
No, what you thought? You thought this is 20.
nothing.
No. What about the distance in 25 seconds? Someone 37. Leave it in roots, Naresh, man. Right, Utsav, वो दोनों right है. Get me the third part also. Neresh, Shaunak, B is not 137.5. What is the B part? 25 seconds? So this is 20, 25 will be somewhere here. So this is 45. This is also 45. So this area will be 100. This area will be half base into height. That will be half into 10 into 10. That is 50. Now this area, if you see, this is 5 and this is also 5. So this will be half into 5 into 5. So the total, this will be the distance travel. Distance, you just add up all the areas. Don't take any plus minus signs. 100, 50. Technically speaking, this is a negative area. You have come back, but you were asking for distance. That's 12.5. 162.5 meters is the distance traveled. If they ask you for displacement, then if you want displacement, then you take this 100, 50, and the negative area is negative, you take 12.5. Are you getting this? When they ask for distance, it doesn't matter whether you're up or down, just add the areas. If you're asking for displacement, then you need to subtract it. The third is a good one. Can you do that? I'll give you a minute. I think some of you got it already. No, that is wrong. Right, Ishma. Third is a good one. Find the time when the displacement becomes 0. So indirectly, you know what I'm asking? This total area, which is positive, at a particular time, we'll get this area. So this green area and the red area are equal and opposite. Isn't that the meaning of it? Displacement 0. Total area must cancel out. So this green area here and the red area must be equal. So what is this time? That was a question. Get it? I'll give 30, 40 seconds. It is just geometry there. No, Shanak. Shreyan's right. नहीं Aditi. You won't get good numbers. Root में आएगा. So this is 20. This is 10. So this area is plus 100. This area is plus 50. Let this time be t. If that time is t, this will be t minus 20. Agreed? This angle is 45 degrees. So this is also t minus 20, the opposite side. So this area will be half into base is t minus 20, height is t minus 20. So you're saying this black area here and this green area here, they should cancel out since displacement is 0. So displacement will be 100 plus 50 minus t minus 20 square by 2. So you're saying this is 0. So 150 is t minus 20 square by 2. T minus 20 is root 300. T is equal to 20 plus 10 root 3. Got this? So this is the time when the displacement is 0. 10 root 3, right, Sudiksha? Right, Pratesh. Yeah, I think most of you got it. All clear with this? Any doubts on this? Let's see one last one. We'll do an easy one. This is a VT graph. Let's say this is 60 degrees. This is 45 degrees. This is 45 degrees. Let's say this is 30 degrees. So let's say this is 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds, 12 seconds. This is a VT graph. Looking at this graph, can you plot AT graph? Easy one. Let's get this. So VT graph is given. You need to draw plot AT graph. This is easy. So in a VT graph, slope is acceleration. So you just need to ask what is the slope. So here the slope is tan 60 root 3. Here slope is 0. Here slope is tan 45 1. Here slope is tan minus 45 minus 1. Here slope is 0. Here slope is tan minus 30 minus 1 by root 3. You should take the obtuse angles, right? Or you can take negative angles. Clear this? The slopes. So you're done. So when I plot AT graph, so for first 2 seconds, the slope is root 3. So it is constant. Then from 2 to 4 seconds, slope is 0. So just put a line like this. Then from 4 to 6 seconds, slope is 1. Again, a horizontal line. Then the slope is minus 1 from 6 to 8. So it will be a negative line. Then again, it becomes 0 for 2 seconds. Then it becomes minus 1 by root 3. There. That is how the graph looks. Is that easy? So this value is 1. This value is minus 1. This is 0, 0. This is minus 1 by root 3. So it is just like a step function. Got this? There. So if I give a VT graph, you can plot an AT graph like this. So they do ask like this also. They'll give one graph and ask you another graph. Okay. There, we saw some basics today. Next class, when we catch up, we will do more varieties of graphs. We will do more little tougher ones. Like if I give a physical situation, how do I draw a graph for that? Mostly next class, we will wrap up with kinematics. And once we are done with this, then we'll go for units and dimensions and errors. Units and dimensions are easy, but errors is very important. At least for advanced, every year they ask 1 or 2 questions. So we will do that because it will be used in most of the chapters that is coming up. Units and UDE, right? There is also a small chapter. I think most it will take like 3 classes. We'll wrap up that. Then we will go to our main topic, NLM, laws of motion. So next class, we will wrap up with kinematics. I already sent you some sheets last time. So you want additional practice, you can do them. But we already touched around 76 questions. So please finish all the notes properly first. It's a big one. After this, such a big chapter again will be rotational mechanics. So okay, with that, we'll wrap up for that day, right? And there's a test online. So make sure to give that also. So any doubts in the class notes? Anything else you can stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you guys again on Thursday, as usual, at the same time.